Hey guys, last set. Here we go. So very similar to number 12 is number 13. At first glance, yes, these are both perfect squares. I can difference of square this. But wait, 4 and 100, those are ones that I know for sure go into each other. And so this is actually going to be a GCF and then a difference of squares. And so the first thing I'm going to do is pull out the 4. And so when I do that, I get 4 times x squared minus 25. And so then I would factor the x squared minus 25 using the difference of squares. And so I would leave the 4 at the front, and then I would go x plus 5 and x minus 5. And that is all I have to say about that. Okay, moving on. This one right here, 3, 19, and 6. Got super excited whenever I saw the 9, realized it was 19. 19's prime, not going to work. So this is going to be an x box because there's not a GCF on this. If I could get rid of that lead coefficient, I could get rid of the box or the grouping aspect of this, and I would not have to work as hard, I guess. But yeah, we do have to do the grouping method. So with this one, we need to figure out two numbers that multiply to be 18 because that's A times C, and then add to 19. And so two numbers that multiply to be 18, obviously 3 and 6, right? No. I mean, yes, but no, they don't add to 19. And so this is one of those that I said, you got to remember that 1 is an option. So 18 times 1 is 18. 18 plus 1 is 19. Excellent. So my two numbers are 18 and 1, both of them positive. So whenever I write this, 3x squared, for me, it doesn't really matter which order we write this in because it's going to be pretty easy either way. So I'm just going to put it in the order that I wrote it to begin with, 18 x, and then plus 1x and plus 6. Now, you know me, I don't really like the 1x's, but here in a second, you're going to see why on this one it's very helpful to keep that in mind. So we're going to group this and we're going to break it down. So actually, I'm just going to group it up here. There we go. And group one more time. There we go. Excellent. So the largest thing I can pull out of that first bit is a 3x, and then I'm going to have x plus 6. And then plus, what is the GCF of 1x and 6? Oh, like it doesn't factor, right? So a 1. And so I'm actually going to write that here. And like I said, I normally don't do that, but here I think it's going to be very helpful to you guys, to me, to everybody. And so then if I divide everything by 1, I still get x plus 6. Remember, both of these terms should be the same. So then I'm going to leave this part blank for a second. And then it's going to be x plus 6 because that's the part that I see twice, and so I write it once. And then whenever I slash that out, let me go ahead and just delete this right here for a second. Delete and delete. That is why I put the 1 there, because if I'm physically scratching stuff out and I just see a 3x, I don't think to add the 1 on there. And so when you're doing it this way, it is very helpful to put the 1 right here so that you can physically see that you are factoring out, and whenever you scratch it out, that plus 1 is part of your term. So 3x plus 1. Okay. That was pretty much the trick on that one. All right, this next one, nice. It GCFs, but it doesn't GCF all the way because 9 doesn't go into 30 or 21, but 3 does. And so there's still going to be a lead coefficient. Since there's a lead coefficient, we are still going to have to do the X box method. And when I say X box, you know that I mean that you can group as well. So yeah, there's that. All right, so we're going to pull out the 3, and then we're going to be left with 3x squared minus 10x plus 7. And unfortunately, we did not do this one already. So we can't just copy from above. And so I'm going to go ahead and put the 3 in our final answer here. And then I'm going, wrong button. There we go. I'm going to let that set. So then we're going to look at what two numbers multiply to be positive 21 and add to negative 10. And those numbers, of course, would be negative 7 and negative 3. And so I've been doing this the entire time by writing, 3x squared minus 3 and whatever. But let me just show you what would happen if I switch those up, because, you still get the same answer. You're still performing the same operations. So 3x squared minus 7x minus 3x and then plus 7. Okay. And then whenever we group this, here's going to be our group, and here's going to be our group, and there's going to be a plus sign, and we're going to start another group. And then there's our group. Okay. All right. So 3x squared and 7x, they don't have anything but an x in common. So x gets factored out, and then you're left with 3x minus 7, because all you did was take the x away from both terms. And then, okay, this one is a negative 3x, so I should probably factor out the negative. But 3 and 7 don't have anything in common, and so it's going to be a 1. And so then you have left a positive 3x minus 7, because positive 7 divided by negative 1 is negative 7. All right. And so now see it twice, write it once, and we're going to put 3x minus 7 in that first container there. And then whenever we slash it, we get x minus 1. Now, could we have done this the same way that we did, what was it, number 3? Number 3 and number 4, where we had that same kind of setup with the 2x and the 2x and the 5x and the 5 and the 7x and the 9x and all this stuff that was exactly the same. Yeah, absolutely. You could have done it that way. But just in case you didn't, this is the reason why I like to do it that way, is because like here, there's just so many things to think about and remember. So I'm like, nah, group them nicely. Group them with their number buddies. Okay. Last one. All right. This one, not everything is a perfect square. There's only 2 terms, so this is not a difference of squares. This is just a GCF. And the only thing that they have in common is that single x. Now, again, this is where some people messed up, is that once they had that x gone, it's like, yeah, it just disappears and it cancels out and I don't have to do anything with it. But the issue is that we are subtracting here. And so whenever you factor that away, x divided by x is a 1. And so with that, you have to keep that 1 there, because it's not like multiplying by 1. This is adding or subtracting. And so it's important. It's relevant. All right, so 5 can stay, x can stay, y can stay, minus can stay, and then that x turns into 1. And the reason that first x can stay, remember, is because there was 2 of them here and we took 1 off. All right. Oh dear, you can't see my answer, my bad. There you go. All right, that is the end of this. Sorry that took so long. I didn't expect to talk so long and have so many typographical errors. My bad, guys. Please correct your papers and resubmit them, and that will be both Monday and Tuesday's work. And so Tuesday I will put a video out there for what it means to solve quadratic equations, but there will not be an assignment going with it. And we will have another video and assignment to go with that on Wednesday. So this is your work for the next 2 days. Make sure that everything is neatly typed out and that everything is, correct, and that you understand where you had issues. If you have any specific questions, please email me. I'm hyped up on caffeine right now, so I feel like I'm talking very fast, but not fast enough, because this is another 9-minute movie. You guys have a great rest of the day. We'll see you later.